Time literally slows the closer you get to a black hole. At the edge, called the event horizon, time stops completely. That means 1 second for you near a black hole could be years or even decades for someone far away. That's not science fiction, that's physics, and it's just one of the wild things black holes do. My name is Blake Hampton, and today I'll be teaching you all about black holes. Black holes are mysterious and not often understood, and they're honestly kind of terrifying. But the more we learn about them, the more we learn about the universe and how it really works. Even though we can't see them directly, black holes are everywhere. They affect how galaxies form, how gravity behaves, and even how time flows. And that means they affect the universe that we live in deeply. I've always been interested in space, probably more than most people. I've read books like Death by Black Hole by Neil deGrasse Tyson, and I regularly follow updates from NASA, JAXA, and Harvard Center for Astrophysics. For this speech, I wanted to dig deeper and understand black holes better, and then bring that information to you. Today, I'll walk you through 3 big ideas: how black holes form, what happens when you get close to one, and how they shape the universe around them. Let's start with how black holes form. Black holes are born when massive stars run out of fuel. These stars explode in a supernova, and their cores collapse under the force of gravity. If the core is heavy enough, typically around 3 times the mass of our sun, gravity wins, and the star becomes a black hole. At that point, matter collapses into something called a singularity, which is a point of infinite density. Surrounding that point is the event horizon, which is basically the boundary where nothing, not even light, can escape. According to the Harvard-Smithsonian Center for Astrophysics, this process creates a gravitational well so deep it alters space and time around it. Black holes can form in different sizes. Some are just a few miles wide, while others, called supermassive black holes, sit in the centers of galaxies and have masses millions or even billions the times of our sun. Now that we know where black holes come from, let's look at what happens when you get close to one. The gravity around a black hole isn't just strong, it's extreme, and as you get closer, light bends, time stretches, and physics starts to act weird. The event horizon marks the point of no return. If something crosses that line, it's not coming back. Outside looking in, time freezes for that object, and from the inside looking out, you're falling towards the singularity and stretching, what is called spaghettification. Dr. Tyson describes this in his book, Death by Black Hole, as a place where tidal forces are so intense, they would stretch your body into thin strands, like spaghetti. And it doesn't just affect matter, it also bends light, making it possible for us to detect them, even though they're invisible. This is how we know they're out there. So now that we've talked about how black holes form and what happens when you get too close, let's talk about how they shape the universe. Nearly every large galaxy we know of has a supermassive black hole at its center. These aren't just features of the galaxy, they shape everything around them. According to UC Santa Cruz, black holes actually regulate star formation in galaxies. As they consume matter, they release powerful jets of radiation, which heat up the gases and slow down new star formation. So in a strange way, black holes are what keeps the galaxies in balance. The Japanese Aerospace Exploration Agency, or JAXA, studies how X-rays emitted by falling into black holes help us measure their size and spin. This gives us better insight to how they grow and evolve. And NASA explains that we can detect black holes using something called gravitational lensing, where the gravity of the black hole bends the light from stars behind it. It's like nature's own telescope. So while they seem destructive, black holes are actually a fundamental part of how the universe is constructed. So in conclusion, today we've covered how black holes form from dying stars, what happens when light or matter gets close to a black hole, and how these invisible giants help shape the galaxies in the universe. Even though they feel like something out of science fiction, black holes are real, very real, and they're essential to understanding the past, present, and future of our universe. And maybe the most mind-blowing thing is, we're really just getting started getting to know them. Again, my name is Blake Hampton, and it has been a pleasure taking you through this journey of the cosmos and teaching you about black holes.